I'm not big on complicating things just for the sake of complicating them. So whenever I'm doing data science, I'm always checking out the new packages, the new tools, and functionality that's available to see if I can refine and simplify my analysis. And one of the tools that came on my radar recently was Facebook Profit. Now, for those of you that are familiar with time series forecasting, you'll know that R is usually the platform or the foundation of good time series forecasting. Has a lot of packages, had a lot of history with it. Python, not so much, right? Python is very new to the game, even in terms of stats models and other packages. But we do see a lot of momentum and a lot of brand new packages that are coming to the fore, including this open source package by Facebook. So just by a show of hands, so I can get to know you guys, get to know what your backgrounds are, but also find out how quickly I can get through this so I can jump into that conga line for the office tour. Who here is a beginner when it comes to time series? So you either know nothing, or you may have played around with it a little bit, but you didn't really know what you were doing. Okay, great. So easily half of the room. Okay, what about intermediate? So you use it fairly regularly. You might be dangerous enough to tweak your models, things like that. All right, good. Any experts in the room? You are an expert at time series modeling. Put your hand down. I know you're not. Any real experts in the room? You can tell by the way they smile at you that they're full of it. It's like, all right, so that's good to know. So I wish I had time to go through this like 8,000 line Jupyter notebook here, but I focused just on Facebook Profit, and we'll go through quickly because I know you guys want to socialize. Couple of key things about this package. So it is a piecewise, either linear or logistic growth curve trend. I'll talk about what that means in a little bit. It's got a yearly seasonal component. I hope we all know what seasonality is, but it's these fluctuations across the year. So holidays or Q4 for retail is huge because people are buying more stuff to give gifts. There are also seasons, months of the year when business is really slow. And depending on your industry, it could be the summer or it could be the winter, right? We also have weekly fluctuations or weekly seasonality. And we definitely see peaks in certain activities on the weekends and lulls during the weekdays or vice versa. You can have other seasonality too, right? You can have monthly, you could have multi-year, you could have quarterly, but Facebook decided to really focus on these because these are very pertinent to them. But what's nice is it translates very well to most people's businesses. Some weekly seasonality, some yearly. And then another cool thing about this is it's got holidays that you can actually provide yourself and basically customize when it should be taking an extra look at those specific dates. We expect interesting things to be happening on these dates. It's built in Stan, so who here is familiar with Stan? Stan? Okay, so if you know Stan, you're probably a fan, right? Stan is very fast, and because of this, we can actually fit models to time series data extremely quickly. Another nice thing is the code translates very easily between R and Python. So whenever they make an update, for one, the other will probably be instantaneous, and it's very easy to update. It's just not going to be as much overhead for the team and for all those who are contributing. One more question before we actually jump into the demo. The foundation of this time series model is called a generalized additive model. Anybody here familiar with additive models? Show of hands? Yeah, very few of you. That's kind of interesting. So additive models are very powerful. Most people have no idea what they are, and I'm going to try to teach you guys in 30 seconds what these things are. So if you know what a linear regression model is, right, you've got these beta coefficients. So beta 0, which is my y-intercept, and then a beta for every single input, right? That kind of limits these models because when you're talking about a beta, you basically have a number. You have a scalar. That's all you can have. We go to additive models, and these things are much more sophisticated. They actually have custom functions for y with respect to each input. So interactions, right? When we multiply x1 times x2, that's basically a basic example of what these additive models are doing, but they're a lot more sophisticated than that. You may ask, holy crap, how do you even solve these things, right? How do you figure out what the best fit is? It's much more challenging mathematically, but there's actually a technique called backfill, which should remind you of the term backpropagation with neural networks. So there's a lot of similarities between these things. You guys comfortable with it? Yes. Yeah, so additive models, very complex, but in a nutshell, they use custom functions which really allow them to be much more powerful than a simple linear model. So we'll jump straight into this. I'm taking a look at Peyton Manning's Wikipedia page views, okay? And as we see here, we have some serious spikes going on. So this is basically days from the first day, just the raw data, and then the actual number of views on the left. Does anybody have any ideas what we may want to do to make this data look cleaner? Group by days of the week? No, we want to keep it on day, just like a linear trend. So normalize it. What do you mean by that?
I mean to have less spikes and just make like a normal distribution.
Okay. What's a great way to normalize this data? Maybe. Anything more simple?
Take the log.
Take the log. That's right. Whenever you've got right skewed outliers, right? What do you do with your distribution? You take the log and we basically normalize all those right skews. So that's what we're doing here. We're doing a NumPy log. Let's take a look at it again. Boom. We've got something that looks a lot better. Now, not only does it look better to us, but it's better for time series forecasting because stationary data is generally a requirement for lots and lots of models, almost all of them. So this data looks stationary. Basically, in a nutshell, that means that the average is not changing over time. So if you looked at different windows of the data, the average wouldn't be changing. And the variance also is not changing. Now, it is to an extent, but it's generally stationary. It's on a spectrum. Here's another cool thing. I told you this would be pretty simple, right? So they followed the sklearn syntax here. And you basically just declare a model and say .fit. To my data. Boom, I'm out. I'm not going to drop this mic because it's not mine. No, we'll keep going. We'll keep going. Thank you. I'll be here all night. So the next thing we do for forecasting into the future is a pretty simple hack here. What we're doing is we're just creating a data frame and we're populating the dates. So it can be a date, in other words, year, month, date, or it can be a date time that includes hours and minutes and things like that. Now, keep in mind, this model is designed to work on a daily level. It can work on different levels, but it does best on daily. Even so, it's really great. It's very flexible and does a good job with other inputs too. So what I'm doing here is I want to look a year into the future and see what future page views might look like for Peyton Manning's site. And I just do a predict on future. So I'm taking that data in. Oh, by the way, a little bit of housekeeping. They need you to explicitly label your column headers. So your dates need to be called DS, and your outcome is Y, right? And I actually did that up here at the very beginning somewhere. Maybe I didn't. Oh, because this one was already formatted as such. But you'll see what I did in the next example. So the forecast matrix that comes out of this has a lot of really good information. We're going to subset it just so we can take a look at the stuff that matters most. So we've got future dates. We've got a y hat, which is our prediction. And then we've got a confidence interval, which is always a nice feature to have for any model. Let's take a look at our forecast, and that is what it looks like. So here we are on the right, and we are predicting basically after Super Bowl 2016 for the next year. Anybody see any trend or maybe general pattern in this data?
Seasonal with the football season.
Okay. So there's strong seasonality. When we get into the playoffs, right, we get spikes on Peyton Manning's page. Now, if you had another quarterback who maybe is talented but is on a terrible team, I'm not going to give any names, right? They're probably never making the playoffs, and you're not going to see those spikes. You might see them peaking in the regular season. But of course, Peyton Manning, he's a pretty winning quarterback, so we see those spikes. Anything else? Let's look bigger picture.
You see his retirement.
Ooh, you're starting to see this guy get into the sunset years of his of his career. So you can see that, he kind of peaked around 2010, 11, 12, 13, 14, let's say. And then we do still have some outliers up here. Of course, these are the actual data points in blue. The prediction is in, not in blue, in black, the black points. The prediction is in blue. And by the way, we can actually have our model predict historical points. Because that's always a good habit to have, just to see how well it's doing previously. Especially if you don't do like a train test split. Lets you know, hey, here's some actual observed values. I can see how well this did. And then we have the confidence intervals in the lighter blue shading. So yeah, he is sunsetting, it seems like. Check this out though. We can actually break the raw data down through mathematical analysis into the subcomponents of time series. And this is just mind-blowing if you deal with time series data in general. We can split these components into a trend, into a seasonal factor. By the way, there's two of them for Facebook Profit. And then we can also look at errors, so random fluctuations, which of course are not really random, but they're attributed to lots of little things that too small to track, things like that. So here's the trend, downward of course, weekly. Is this what you guys expected? Okay, Sunday is kind of expected, right? But Monday is actually the peak day that people are going in and checking out the Wikipedia page. That's interesting. Maybe it's a combination of, hey, I actually have time to geek out a little bit now that I'm at work. I should be working, but of course, what we all do is we check our, fantasy football stats and see how we did, and maybe Wikipedia is quick at updating it, things like that. Okay. Monday morning quarterbacks, there you go. Yeah, armchair quarterbacks, of course. And then we have the yearly. So as many of you have mentioned, we see this yearly seasonality where nobody really cares about Peyton in May, June, July, and then all of a sudden they're really interested with the start of the season, which we're about to get to here. And, of course it peaks up here because he usually goes pretty deep into the playoffs. Let's keep going here. There's one key thing missing here, and it's holidays. And these are not Christmas with Peyton or Thanksgiving with Peyton and his family. These holidays are the playoff games and the Super Bowls that he did showcase in or feature in. And we can actually split these up separately. So we've got the playoffs here, and we've got the Super Bowl here. Quick note on this guy, lower window and upper window. I can actually designate spillover. So if I did like a -2 on the lower and a +2 on the upper, that holiday is so impactful, maybe it's like 4th of July or something for your business, that it's going to impact the 3rd and the 5th of July. And we would expect to see something like that for big holidays like Christmas and 4th of July. So we'll bring these guys in, and then we're going to take a look again. And once we actually do our forecast, we can see the effect that various Super Bowls have on Peyton Manning's play. The cool thing is here, so check this out. What are we looking at here? What do you guys think the lower bars are? Or to rephrase this, did Peyton Manning make the playoffs in 2012? He did not, okay? Which Super Bowls do you think he featured in? Yeah, 2000. So he's played in 4 Super Bowls. He's won 2 of them. So he played in 2007. We don't have this data. 2010, 2014, and of course he won in 2016. All right. And then weekly looks the same and yearly looks the same too. So on to something more existential here, not Tom Brady. More existential than that. Predicting carbon dioxide emissions, okay? This data comes from Mauna Kea in Hawaii, a beautiful place that I've actually climbed a number of times. And on top, you've got all of these satellite observatories and a bunch of contraptions for collecting atmospheric data, including CO2. So we're going to bring this in. We're going to actually bring this in from Stats Model, which is nice. Rename the columns to get everything into the right format, and go to town. So fit our model. Take a look at the monthly frequency. So if you're not a daily person, or your business is not a daily, then put in a capital W or a capital M or a capital A, confusingly, right, for annual, if you wanted to do your analysis on larger time frames. We can include the history. This basically means, hey, take this model and try it out on historical data also. And we will follow the same procedure here, and we will forecast our future. Again, this is on the monthly level for 120 periods, basically 10 years into the future from, I believe it was 2003. So this is what CO2 emissions look like, right? The trend is not very good. There's the yearly. Interesting, right? We've got a peak around May, June, July, and then a lull in the autumn months. Okay, last thing, and then we're gonna join this conga line, right? So the reality of growth and change with data is that some of it is limited, right? For Facebook, their growth is limited. It's not very limited. You may think like, wow, it's kind of unlimited growth, but it is limited by the population of the world, right? And let's clarify, the population of the world that has access to the internet, that's why they're actually putting these balloons up in the sky, to give everybody Wi-Fi so that they can all browse Facebook. But we don't want to use a linear time series forecast for this. Because it's a line, right? We don't want to use a line. We want to use something that's very natural to the way we see things growing and tapering off asymptotically in nature, and that is a logistic growth curve, and it's well defined or fits really nicely with the sigmoid curve, if you guys are familiar with that. Anybody that's done logistic regression, remember the sigmoid curve is bounded between 0 and 1. In this case, we naturally bound the sigmoid curve with a cap on the top. So this is saturation for city of Chicago, right? If we are building an app, this is the limit of the number of people that could theoretically use our application in the city of Chicago, Midwest, United States, you name it. So that's what I did here. I set a cap. Here's a cool thing. Because we can actually manually do this and we just literally create a column in a data frame, we can change that cap over time. So as more and more people have access to the internet, Facebook can just go in and algorithmically add one every single day, or some sort of function that just slowly increases that cap over time. So you can do that also. So we do this, we include history equals false. In other words, hey, just really focus on future predictions. By the way, that doesn't negatively affect your model. It's just a different kind of view when you plot it, and that's what it looks like. So I wish this was the case, right? There was some natural cap with CO2. It doesn't seem like there's a negative feedback loop there, but if you do have situations where there's either negative feedback loops or caps, this is a great way to use that. So the question again, hey, why should I use this thing, right? Maybe I'm familiar with ARIMA models, for example. I use Stats Model, I play around in R, with the stuff that already exists. Why use this? Again, it's built in Stan, so it's very fast. It's very fast. It usually fits much faster than most other approaches. Out of the box, its performance is typically on par with an ARIMA model that an expert has taken considerable time to tweak. And all of this comes from that GAM foundation, the Generalized Additive Model. It just delimits the model in what it can do. So again, it's not for everything, but does super great for weekly, or daily and annual seasonality. And I expect to see updates in the future also with functionality there. So thank you guys, and I'd love to answer any questions you have about it.